First question is a functions question. They want you to find the points, so probably more than one, of intersection where these two graphs cross over. Possibilities for this are drawing it out, graphing it fully, and hoping that your graph is clear enough that you're able to take the points of intersection off it. Or maybe throw it into your calculator and see if you can find common points through the function button. But I think to me the easiest is if you're doing points of intersection. To me, points of intersection are simultaneous equations. So y equals x squared minus 3x plus 8, and g of x, or y, equals minus x squared plus 4x plus 12. I can either use either of my Leaving Cert or Junior Cert simultaneous equations. I'm going to use the Leaving Cert one, where we take maybe the easier equation, we isolate the x or the y, so that y is isolated, and anywhere you have a y, you sub this in instead of it. So really, like, some people will actually even say you're letting the two functions equal each other in this situation, because that's equal to y and that's equal to y, so therefore they're equal to each other. And I'm going to bring everything to one side. So that's 2x squared minus 7x minus 4. And then all you have to do is solve that whatever way you do it, minus b formula, or I'm going to just do it by factorising. So it's the factors of 8. That subtract to give me 7. So x minus 4 is one factor, 2x plus 1 is the other, but each of those equal to 0. And we see that x is equal to 4, and x could also possibly be equal to a minus 1 over 2. Find the points of intersection. So it's 4 something and a half something. And how do we find the y? Well, go back up here to the top, or wherever you want. Y is equal to x squared minus 3x plus 8. So when x is 4, y is equal to 4 squared minus 3 times 4 plus 8. So that's 16 minus 12 plus 8. Just 12. So that's 412 is one place where they intersect. And then when x is a half, so we're going y is equal to a half squared minus 3 times a half plus 8. So that's a quarter minus 3 over 2 plus 8. Again, just throw that into the calculator. And we get 6.75, or 6 3/4, whichever. So there's the points of intersection. Still on a functions question here. The next bit. So we have our function here. This says that the inputs are real, so your domain are real numbers, and your codomain, or your possible outputs, are also real numbers. So that's why the graph is connected. It's not just natural numbers and